welcome to today's broadcast with Smoltek. That's going to present a strategic update here. And after the presentation, there will be a Q&A. So if you have any questions, you can send them in via the form to the right. And with that said, I hand over the stage to you guys.
Thank you very much. It's a pleasure to be here. Today we are here mainly to answer your questions, and I'd like to make an introduction in English about the company. Together with me, I have Elinor Emberg, who's president of Smoltek Hydrogen. She brings long industrial experience and has a PhD in technology transitions and business strategy. And I also have Fartan Gavani, who is the CTO of our company, and he has a PhD on our core business, the carbon nanofibers.
Thank you.
So with that, I would just like to go into the presentation to bring you all up to speed, and then we'll ask as many questions as we can. Here we go. So Smoltek, it's really a true deep tech story, and the company was funded back in 2005, and the intent has always been there to work on the nano carbon fibers, and it's built on 20 years of research. We have a very good laboratory in Gothenburg at Chalmers University of Technology, which is actually a magnet for talent. So we have roughly 22 employees, with many with PhDs from around 10 countries. And the lab MC2 at Chalmers is one of Europe's biggest, actually. So it's a big asset for us and for Sweden. And it's funded a lot by Knut and Alice Wallenberg Stiftelse Foundation. And the vision is to actually improve our world by working and solving very advanced engineering problems on the material side. We have worked with many applications with nano carbon fibers, and we have now several business applications that we are trying to commercialize. So the picture you see down to the left here is actually from Farsan's PhD thesis. And what we are very good at and unique is that we can, with our know-how, use very precise engineering to place the nanostructures and make them grow at the exact places and control this process. So there's a lot of capabilities as well as intellectual property in our company. So we have strong IP portfolio, 110 patents filed, and we're also compatible with industry standards. So the last few days we've had quite a good news flow. Yesterday we announced that we are breaking the 1 microfarad capacity density, which we're very proud of. Farsan can probably answer more questions about that later. And today we just announced that we have a successful fuel cell electrode test with the leading automotive manufacturer that we're also very proud of. This is paid work for these tests, and we are now proceeding in collaboration. And Elinor will be able to answer questions about that later on.
Yeah.
So what we are working on is actually now going from technology development to industrialization. And we have a couple of very strong macro trends supporting our business. We are in very advanced stage here now with several industrial players, and we have a great team working. So there are lots of very interesting aspects about this company that we will try to dig into details. So our society, we have of course a very high interest now in the computing side and AI, which is driving the semiconductor part of our business. And then we also have the green transition that's also driving our business. So two of the biggest trends in society are actually behind us. Just to give you an aspect of the business opportunity here, we have AI and computing, and NVIDIA, who is the leading player in this field, in their quarterly report, they said, okay, just replacing today's data centers with new new chips and new processors will be about $1 trillion opportunity. And then adding on all the, let's say, new applications based on AI and the coming needs, the next 10 years going forward, they say, okay, it's about $2 trillion more. So this is a huge investment opportunity. And about 5–10% of the cost of the components are actually related to capacitors, which is our target. So there's a big market for us. So what do we actually have here? Well, if we just want to make a comparison with here, we have roughly, if you take one here, it's 50 to 100 micrometers. And if we split them 70,000 times, we get 1 nanometer. So this is extremely small, and of course we have to use an electron microscope to see our carbon nanofibers, and we have some pictures here below of how these look in the real world in high resolution. We have to say. What we can add here is that this can of course be used in many applications, and we have started out with semiconductors, capacitors. We started out with discrete capacitors, and then we see that there are also possibilities for integrated going in the future here. And also we have worked on hydrogen. We have worked a lot with PEM electrolyzers and fuel cells. And we also see opportunities in energy storage and medtech. But we are focusing very hard on these two business areas to start with. So the market for capacitors, it's actually a very, very big market, but if we slice it down to the ultra-thin silicon capacitors market, it's roughly $2 billion last year, growing at a pace of roughly 6% per year, compounded annual growth rate. And we see lots of segments actually here, and some very big players, component players that are positioning themselves in this field. This here is a comparison between Smoltek's carbon nanofiber MIM capacitors to the left, and then the competitors that use a technology called deep trench capacitors. And what you see on the pictures below is that in the middle you have our competitors, and that's how they dig into the silicon trench, and how we to the left can get a lot more carbon nanofibers packed into the same space, and that way we can actually get a much higher density, which is our key here. And another big advantage with our technology is that we can reduce the number of ALD steps from 3-4 to 1, which has a big cost implication, a big cost advantage, which is very important going forward. Since this industry is very much a mature industry where it's cost, performance, and reliability. That's kind of the key words. So this slide here shows us the, let's say, plan for the various generations we have in pipeline. We are currently working on generation 1. We hope we have some really good engineering samples and prototypes from generation 1 later this year. We can probably also answer some more details about that later on. And we had this news coming out yesterday with the dialectric stack, which means that we actually meet some of our requirements on capacitance density already now. I don't know if you want to add something to this slide on right now, or? No, I think. Okay, very good. So we have a strategic plan that we're executing. We have covered many milestones here, and we think that we're in a very, very interesting time right now, where we are just about, on the verge of going into industrial negotiations. So that's a really, really interesting time for the company, and for me as a new CEO, it's great to come in this phase where we go from the technology development more into industrialization. On the competitive position, oops, sorry, that was one too many. There we go. Sorry about that. Well, our competitive advantages is actually higher performance. We can be cost competitive on production processes. We have a more robust technology, and we can be more temperature resistant. And we have freedom to operate. We have the IP, and we have all the freedom to work in the areas that we choose to compete in. So we think we're in an excellent competitive position with our technology and our offering. All right, so I'll move over then to green hydrogen and our business there. We have several areas in society that's impacted by green hydrogen, and we have chosen to focus on the PEM electrolyzers, and lately quite a lot on fuel cells as well. And of course the press release today was in the fuel cell area. This slide here is showing how big investments are projected to be in Germany the next 20 years, and it's 900 billion euros invested in CCS and also electrolyzer technology. So it's a huge market. We see that the technology develops and cost will come down to make this growth happen, and we're very well positioned there. Our solution is a porous transport electrode, which is what you see on the picture down to the right. And it goes into cell that goes then into the stack, which is actually the heart of an electrolyzer. So you see the full electrolyzer in this standardized container solution. And our part there is the vital part to make this process happen as quickly as possible, as efficient as possible. And what we do is that we actually reduce the iridium loading by covering the nanofibers that we produce, our carbon nanofibers, with particles. And we have a very good picture of that here. So what we have done here together with Heraeus is that we take our nanofibers, you see on the blue picture down, and then add their catalytic solution. And then we have an unique product that has a lot less iridium than our competitors. We are down to 0.1 milligram, which is, well, we have announced before it's 95% less than competitors, but we're very proud of where we are, and we have lots of interest. And we have also announced a cooperation with Heraeus, which is one of Germany's largest family-owned companies. They have a big focus on precious metals. So together with them, we are now going into this field together. And Smoltek hydrogen has been in the news quite a lot. So we are seeing great progress there. Where we are now in terms of actually creating values to the shareholders, we are in a phase where we have technology validation and we have commercial validation. And we think there is a huge value opportunity right now because we see this happening. And as you see with the press releases, we are actually getting paid for sending prototypes to one of the largest automotive players in the world. And we are also in very interesting dialogues on the semiconductor side. And we are delivering on the technical validation that's critical. So what we see here is that with some of these pieces in place, we will create lots of value for our shareholders and our backers the next 2 years. And of course, the big value creator will be a license agreement or a bigger offtake agreement with an industrial player. And there are various ways to do this. It can be licensing with royalties. It can be other structured transactions, or even investments from one of these industrial players, which we think will be a natural next step in our financing journey, finding one industrial player that backs us for the next leg in our journey. So that is kind of the key priority for us now this fall. So why invest in Smoltek? We have a very innovative deep tech in our company. And it builds on a long experience, and we have many people that are actually in the company since the founding of the company. Farzan has been here for a while. We have also other people that have been in the company for a long time. The timing is right. We have worked many years and we spent lots of resources, and now we are seeing that finally we can kind of pick the fruits of these efforts. And we have a very experienced and competent team. And there are many other application areas that we can expand going forward. So we are also, of course, dependent on raising financing. So right now we have a rights issue launched this week, actually, that will go until the 24th of June. There are some details about this here on the slide. And I advise you to go into our webpage, Smoltek, to see on our investors page there the full offering. And now I would like to actually leave over to you, so we have the questions.
Yes, thank you very much for the presentation here. And as you mentioned, we will now carry on with the Q&A. And as I said in the beginning, if you have any questions for Smoltek, you can send them in via the form to the right. And I think we shall go ahead with the first question here. And I would like to understand more about the press release issued yesterday regarding the new dialectric stack, if I pronounce it right, and what it means for Smoltek's generations 1 or 2.
Farzan, please go ahead.
Yes, so one of the most important aspects of the technology we are developing at Smoltek is being able to deposit a very thin dielectric stack on carbon nanofibers. And we are continuously working on improving this dielectric stack, both in terms of thickness and in terms of dielectric constant. So what we published yesterday was, for the first time, something we always knew, but now we proved that in the lab, that we could cross the 1 microfarad per square millimeter barrier. And that's a very important milestone for us. And it really brings us in the same league as the leader in this market. So we are very proud of that. This is not the end game. Of course, we are continuing, and now with the collaborations that we have set up over the years, we are confident that we could continue to press this number up, and the team is very proud of that.
Yeah, it means a lot, in other words.
Yes,
yeah.
It does.
Yeah.
It does.
Sounds good. And also, there has been a lot of speculation in social media that Murata was Smoltek's first customer, for CME first customer. Why was that agreement cancelled?
Well, first of all, they were not the first customer. It was actually another player. And we cannot, unfortunately, tell their name, but they kind of decided that they want to pursue their other internal technology leg they had going. So we of course thought that was very sad, but that's often the way it is. You compete with internal R&D and tech, but now when we have delivered, we can pretty much go back to them and say, okay, here we are, what have you done? And we maybe can take up the dialogue again.
I understand. And a follow-up question there. What is the status of now with the customer 1?
This is the customer 1.
Yeah, okay, yeah. Good. And I think this one for Eleanor maybe, but you have today announced that you have achieved successful result in fuel cells with a global vehicle manufacturer. Why do you test? Why you testing fuel cells? Electrolyzer, right?
Well, let me take it from a helicopter view. Green hydrogen. I'm not sure. I think people know much more about semiconductors. So green hydrogen, the purpose really of green hydrogen and all the development that is happening there is to get rid of fossil fuels and fossil input to also chemical industry and so on. And we all know that electric cars, for instance, that's really one way of getting rid of fossil fuels. But there is a big problem there, and that is that quite often when you're transporting, you have heavy loads or you go very far distances, then the batteries, if you want to make these vehicles electric, the batteries would be far too large and heavy. So then you use hydrogen instead. And to use hydrogen there, you actually, here it comes by what you need the fuel cell for. Because a fuel cell, you take hydrogen and it's converted into electricity. So then in these, for instance, in large trucks or in Sweden, we drive our trains on electricity, but elsewhere, most countries drive trains on diesel instead. Or if you look at marine transportations, heavy transportations with and so on, there instead it's impossible to do this with batteries. So you put you put a fuel cell in that, and then you fuel the vehicle with hydrogen instead. And the hydrogen, it weighs far less compared to electric to lithium batteries. So that's why that's why you use fuel cells quite a lot. And then, of course, you also need to produce the hydrogen, and that is what we do in the electrolyzer area. The thing is that these two processes, an electrolyzer, you take electricity and you make hydrogen. Fuel cell, you take hydrogen and make electricity. They are very similar. So that's for us. When we started it, we are focusing quite a lot, and we have some really unique things for electrolyzers. But then when we also found some very smart ways of using what we have for fuel cells to use for electrolyzers also in fuel cells. So with our carbon nanofibers, when we put them inside a fuel cell, you actually get much more electricity out of the hydrogen you put in. You reduce, it's called contact resistance. Yeah. So that's why. So we happened to make some really good patents. We published about it, and then it got really quite a lot of attention. And one of the absolutely largest vehicle manufacturers contacted us, and we made a number of prototypes for them, and now we have tested them, and with really successful, really good results.
It sounds really interesting and very, very nice to reach that milestone as well. And but how do you see the growth of the hydrogen market maybe going forward?
Yes, at the moment I would say actually fuel cells are growing, I would say, faster in a way. It's more, they are smaller, and you need really big permissions and so on to set up to produce hydrogen, because you do that. That's really large. Electrolyzers are often really large facilities, while fuel cells, you put them in cars or in boats or airplanes. So for that reason, it's easier to get going with that. But long term, you will need to produce the same amount of hydrogen that you're using. That is one thing. And secondly, also, when it comes to electrolyzers, green hydrogen is not only to be used in fuel cells. There are so many other applications as well, like green steel and all
Areas.
nutrients, all that kind of stuff.
Yeah.
I mean,
of course.
we are a green company and we want to participate and help in the transition. But one of the things with fuel cells is that they can use any kind of hydrogen, so it doesn't have to be green hydrogen, which is still quite expensive to produce. They can also use hydrogen coming from, let's say, LNG or other forms. So that's why that business is not so dependent on cheap green hydrogen. It's growing, even if, let's say, cost of green hydrogen.
Yes, it's an emergency solution. But I mean, you don't save any. It's very expensive to drive with fuel cells. So as long as, if you cannot get it, but otherwise the point is to use green hydrogen, of course.
Yeah, so just to sum it up, there is a big demand, if I read correctly here.
Absolutely. And there was a big hype around green hydrogen a couple of years ago. And as always with new technology, many companies plan to be number one and overinvest. So we got a lot of overinvestments. And now we see actually a bit of a shakeout, which in a way is pretty good, because it means that the ones that actually still are there most likely are the ones who will be the winners and will have those big volumes 2030 that we have sort of as a target.
So you could see there's the competitive situation has a lot of competitors have fallen away in this period, or
yeah, and in particular the companies investing in electrolyzers themselves, the ones who would be our customers. So quite many of them we see disappearing, and then people start talking about a downturn. We are focusing on things that will come to the market in a couple of years. So for us, it doesn't really matter if they are there or not. We are working with the one who will be in the future.
Yeah, and just adding to that, I mean, our competitive position will then be to help bring down costs of the electrolyzers, which is a key thing in the next generation, and of course the iridium. So you know, we have a big contribution in the next gen, so to speak. And also about the market, of course, it's different in different regions. We see the problems in the US with all the Biden subsidies, and now everything is reversed. But in Europe, and especially Germany, where we focus, we still have a solid and good market, because Germany has to do something in their Energiewende. So I think we're well positioned.
And the main thing still with our electrolyzer is that there is no way the amount of iridium that you can get today will be enough for what is actually needed for the green transition. So there will be not enough iridium for what is needed in the future. So that is why this technology race about iridium has been going on. But the traditional technology has really reached a stop physically. So that's why the new way, what we are doing, we are taking the lead in the transition to do it in a different way. So they, more or less, I would say, traditional technology have reached the end at 0.2 milligrams. We are starting at 0.1 and believe we can go much lower in a number of different ways.
It's going to be very interesting to follow as well. And looking a little bit, there's a lot of questions here, so I think we'll carry on here. But what happened in the process with Yajio, and what did you negotiate with?
Yeah, that's a question that we have had many questions about over time, and we also issued a press release back then when the joint development agreement was put on hold. But we have kept the cooperation with Yajio, so Farzam can tell a little bit more about that. But what happened was that we negotiated with the capacitor division, so to speak. It was called MLCC, but it's all capacitors within the Yajio group, and they were big proponents of doing this together with us. And then they brought it up to the top management in Taiwan, and at the end of the day, there was a decision at the top management level, and even the chairman was involved, that for financial reasons they had to pause it because they cut their R&D budget considerably. So, but I have actually a citation from Robert Willoughby, who was then our counterpart, and he's still very active, and he has actually a bigger role now in the company. And he said back then that he is open to kind of look at the decision again, and they are convinced that Smoltek's innovative technology will create excellent products going forward with disruptive properties compared to the present products in the market. So he was then, as in this citation, very keen on cooperating with Smoltek, and the company has delivered according to the milestones we decided with them, and we have funded it ourselves, and it's been expensive, it's been hard, but we're very proud that we're now, at the level we said we were, and we have also a good dialogue. So you can please...
The collaboration continues as strong as before. Yajio just stopped funding us with direct cash. We still, as of today, we are using the very expensive infrastructure they have. They have offered it to us for the development we are doing. We are using the test facilities they have. We are using the microscopy facilities they have. We are using their engineers to do simulation for us. And we have very good communication, both at the management level and the engineer-to-engineer level. So I would say that the collaboration is as strong as before. The nature of it has changed, but we're still working very closely with each other. And I think the investment they're making, and it shows that they still believe in our technology. So we'll see where it takes us.
Very interesting. And a question from the chat here as well regarding electrolyzers and the iridium savings. Are there any downsides with your technology that would make customers stick to their existing technology?
No, I would say there are a number of different types of electrolyzers, and we are working with what's called PEM electrolyzers with the membrane inside. And this, there are no alternatives to using iridium. They have tried for over 100 years. The cost of iridium is around up to 2 million SEK for 1 kilo. A little sort of very, very small piece. And it's expected to reach at least 8 million SEK, 2030, and later up to 20. I mean, it will not be available. But it is the only solution for PEM electrolyzers. Then people say, okay, but why don't you use the other electrolyzer types? The biggest one is the alkaline. The problem with the alkaline is that you cannot use it with sources wind and sun, because you have sun in the day and then it's dark in the night, so you need to be able to switch the capacity. That is not possible with the alkalines. You do need to have PEM electrolyzers, otherwise you will always have extremely inefficient utilization of wind and sun electricity. Because with this, you can produce a lot of green hydrogen when it's a lot of wind. And then you can store it and use it. You can produce hydrogen even when it's for free, and then you can sell it when the electricity prices are very high. So no, there are no alternatives. We are working a bit, you mentioned it as well, with the company Yajio. They have found a way to also, there is another material called ruthenium, for instance, that you can use. It's a very good catalyst, but it doesn't last very long at all. But so what they have realized is if you mix it with iridium, then you can also use much less iridium. But still, only they today are working on the old version where you put it on the membrane and use very thick things. That is what we are so we are putting their sort of disruptive way of doing the catalysts on our disruptive way of putting it on the titanium, which is sort of a it's not just 1 + 1 is 3. It's 1 + 1 is 10.
I understand. And looking a little bit on engineering sample, what is the main purpose of these, and how do they fit into the customer dialogue?
I think we're back on the semiconductor side.
Yeah.
Do you want me to take that?
Yes, please.
Yeah, sure. So you know, before you go to high volume product, when
Yeah.
you go to products that you can sell, you need to engage with your customer as early as possible. You need to make sure that the requirements they have are taken into account in the development phase, and once you have them product ready, there are no surprises.
Yep.
So the purpose of engineering sample is to provide this communication channel with customers, so they could use a sample which is not really for mass production, but it has all the properties that will be there at the time that we go for mass production. They could take that, they could integrate that in their system, they could evaluate it, they could see, you know, the advantages, disadvantages, and give us feedback. That's an important tool in our toolbox to go into mass production.
Could you say there's a type of proof of concept thing, or?
Yeah, so engineering samples are usually more mature than proof of concept.
Yeah.
Proof of concept, as the name suggests,
It's
just tells you that, you know, earlier stage that this works.
Yeah.
But it's not only that it works in the conditions that the customer intends to use this component in the future. So it's one step ahead. It's just a step before the actual products.
Thank you. And regarding the fitness of the Gen 1 with 10 micrometer fibers, as they seem to be discrete units and built on silicon, have you managed to thin the silicon in the back-end process compared to previous lab prototypes of 40 micrometers that was communicated as the word thinness capacitor? Right. Long question.
Yeah. No, I think it's a good question. I think we have communicated before that one of the main advantage of carbon nanofiber capacitor is its thickness. And that is because the silicon trench capacitor use or exploit the bulk of the silicon to make the trenches. Yeah. We don't do that, and we grow fibers on top of it. And we have much higher volumetric capacitance density, so the active area is shorter. This enables us to thin the silicon down more aggressively compared to our competitor. Yeah. We showed that we could thin it down to 40 micrometer before, and I think in Gen 1, now the emphasis is not to show the thickness anymore. We have to focus on other KPIs, and that's what we're doing in Gen 1.
Thank you. And looking a little bit here, is there exclusivity with any industrial player on the semiconductor side here? And what is, take that one first.
Yeah, that's also a good question. We had in the agreement with Yajio an exclusivity clause, but since they stopped funding us, we are now free, so we don't have any exclusivity with any player. So basically, we are open for business with various industrial players, and that's also how we think we can, you know, create very interesting road going ahead for our shareholders by, you know, see if we can, you know, approach several players here.
Sounds very good. And you have mentioned Heraeus before here, but what are you going to do in the collaboration with them? Can you bring some more color into that, maybe?
The collaboration with
Heraeus.
Heraeus, yeah. Yes.
With Heraeus, as I said, we want to work together with them. But all in all, I would say we are actually we are building, I would say, a network within the whole ecosystem of electrolyzers. I mean, everything from catalysts to the coatings to the different materials inside the cell, putting it together into stacks, and you have so there are a lot of different actors we are working with. And as I mentioned, Heraeus, they play a key role in that they are the technology leader when it comes to the catalyst, the iridium. So, but I can mention maybe we also are working with, announced a cooperation with a Swedish company called Impa Coatings.
Yeah.
And they are also in more or less the same area that we are, but they work with other coatings, but for same customers. So there we see a really good synergy that we could sort of, we're trying to see how can we work together in business, in selling, blah, blah, blah. That is one thing. But also their business is also to make machines. So we are evaluating how can we use the equipment that they have for producing our stuff. Are there sort of any easier ways perhaps for us, because we have plans for big investments as well, but I mean that's not really where we are right now.
Yeah.
And can we together with them find something easier, cheaper, they are closer to us, and they also provide customers. So there are we see a lot of different really good areas to cooperate with them, and also to try to bring them together maybe with all the others we are working with, and they bring us to their so like being really good friends. That's where ecosystem and really good friends with them, and some others as well.
Just a small follow-up question there. Is there any like timeline for evaluating such a collaboration that maybe investors should look at in the news flow?
I think they just have to follow us. So much is happening, so they just have to keep track of our press releases and stay tuned.
Moving on here, we have a few questions left here. What is the status with the HVM machine?
That's a high-volume manufacturing machine that we ordered a few years back, and now things are happening. So,
so we received this tool. This is a very expensive tool that is one of the key enablers for us to go to high-volume production. And I think we communicated multiple times through the press releases that now we are moving the fabrication line to Taiwan. This is because to be closer to customer. This is because of the agility we have there, and for cost reasons and time to market reasons. Now we have set up a pilot line there together with the foundry called E3. And now the next phase for us is to move the tool, this high-volume tool, to Taiwan. We are working on the details. We are very close to finalize it now. And it's a complex tool. So you want to make sure not only all the technical details are in place, but also there is a long-term roadmap. And the collaboration has a long-term horizon that once you transfer it there and make a huge investment, that is used, that's divided the cost over many years. So I hope that we could come back here in autumn with good news, or after the summer. We are really at the final details of fixing this.
And let's see, I received one last question here from the chat as well. You're not right now carrying out a rights issue. You have, if you have listened to the presentation, they have some extent understand what the money will be for. But could you just sum it up? What will the money be used for?
Yes, that's a good question. We want to use the main part of the money, of course, to fund the development activities and the organization we have going. But we also have some investments in key equipment related to this machine, as you just mentioned. We're also about to install an ALD, atomic layer deposition machine, at the Chalmers lab. And we have some investments on the hydrogen side, on a pressurized chamber and a couple of other things. So there are some investments, so to speak. And then, of course, we want to have the capital so we can take those negotiations with industrial players without being forced into anything. We want to have a financial strength to get the possibility to negotiate the best deals we can get for the company. So the money will bring us to basically to the end of this year. We have applied for various money from EU and other programs on both business areas, so that could be also coming in. But we think that the next financing round will be with an industrial player, basically.
That was all the questions we had here. So thank you so much for presenting here today. And if somebody watches this later and not have followed the live, should they contact you if they had any more questions?
Yes, please do. And I think on the last slide here, there were the contact details at the bottom. So please email me or contact me, and I'm happy to answer any questions.
Thank you so much. And thank you to all there at home watching, and have a nice day.
Thank you.